Hi Year 11, hope you're all well. So I'll be doing a series of videos to help you with your revision for your mock exams. I will be focusing on exam questions to help you gain confidence in answering exam questions. Please remember the topics for paper 1 are C1, C2 and C3. And then your topics for paper 2 are C4, C5 and C6. Today I'll be focusing on C3 and we will be looking at oxidation, reduction and electrolysis. In your revision guides, this is where you'll see oxidation, reduction and electrolysis. It's the back end of C3 and it goes all the way up to here, electrolysis of copper sulfate solution. You're going to use panic and oil rig to help you remember the names and charges of the electrodes. So panic, positive is the anode and negative is the cathode. So positive is the anode, that's the positive electrode, negative is the cathode. The positive and negative are the charges. You also need to know oil rig. Oil rig, oxidation is the loss of electrons. And if something's been oxidized, it has also had oxygen added to it. Reduction is the gain of electrons. So if something gains electrons, it has been reduced. And then it will be the opposite of this. If oxygen is added for oxidation, oxygen is removed for reduction. And you need to know this because you need to state what happens at each electrode. You need to know what a cation is and what an anion is. Cations are positive ions and they are metals. So here we have magnesium and potassium. Sodium is also a cation. The anions are negative ions, so we've got an iodide ion here and fluoride. So the way I remember it is cation. Can you see that there? That's the positive. And anion has the N in it and that's the negative ion. It's just another trick to help you remember. So now we have this information here. We can label an electrolysis diagram and we can use this information for any example that they give us. So you might get asked what is electrolysis, and it is splitting a substance using electricity. And that can get you a mark. Or you can say splitting up an ionic compound using electricity. Now this diagram is a basic setup of electrolysis. We'll use this and then we'll draw it again. This here is the power supply. And you need to label that on. You can also call it a direct current or a power pack. So as long as you label this, you will get the mark. Then you have your two electrodes here. This electrode will be the positive electrode here. Don't know if you can see that. That's the positive electrode here. So if we use panic, positive is the anode. So we can name this electrode the anode and we can put a plus there so we remember it's positively charged. This electrode here is negatively charged, and this positive is anode, negative is the cathode, so we label this the cathode and then we'll put a minus to remind us it's negatively charged. Then you will have to say where the ions go. This here, the solution we are trying to split up, is called the electrolyte. Okay, and in our example we're going to use sodium chloride. Now, you do need to remember that if an ionic compound is solid, you cannot conduct electrolysis on a solid because the ions are not free to move and carry the charge. That's what you need to say. However, if it is molten, that means melted, your ions are free to move and can carry the charge. So you need to say the ions are free to move and can carry the charge. So please remember, if it is a solid ionic compound, you cannot carry out electrolysis. If it is molten, the ions are free to move and you can carry out electrolysis. And you can get up to 4 marks for labelling the electrolysis diagram. Let's run through an example now. In an exam, if you see this diagram, write panic down the side. Positive is the anode, so the positive electrode is the anode. Negative is the cathode. The solution we are trying to separate using electricity is the electrolyte. Now remember the positive ions, so these red ions are positive, the name for them is the cations. And these are negatively charged, so these are the anions. Okay, the example I'm going to give you is sodium chloride. So you should know from bonding, sodium has a +1 charge and it is a cation, and chlorine 1 minus charge or minus charge and it is the anion. So you will have to describe what happens during electrolysis, and you need 2 sentences. Once the power supply is on, you can say the cations, or you can say the sodium ions, positively charged ions, are attracted to the negative electrode. Okay, so the cations, the positive ions, are attracted to the negative electrode. That's the first sentence. And the anions, or you can say the chloride ions, are attracted, and this is the word examiners look for, to the positive electrode. And that is how electrolysis splits up an ionic compound. This is an exam question. You need to label the diagram here. So here is the plus sign. So write panic on your paper. Plus positive is the anode. So label this the anode. Negative is the cathode. So we can label this the cathode. Electrolyte is what we are splitting up. Next, sodium chloride is an ionic compound. It will not conduct electricity when it is a solid. And we talked about this. Sorry, you can't see the charges. So if it's a solid, it cannot conduct electricity. However, when it's dissolved in water, or the other word is when it's molten, it can conduct electricity. Explain why. So there's 2 marks here. We need 2 points. The ions in sodium chloride in the solid are not free to move. And then we can say the ions in sodium chloride solution are free to move. You can also put on there carry the charge. This last question here, you have been given some ionic compounds. They have told you the product forming at the negative electrode. So if it's a negative electrode, it attracts the positive ions. You need to state the product formed at the positive electrode. Now here is your thinking. If it's a positive electrode, it attracts the negative ions. Now look at your formula. Lead is a positive ion, so it goes to the negative electrode, and then you have bromide ions. You don't write bromide, you write bromine as the product, so bromine is formed. Here, KBr, potassium bromide, they've given you hydrogen. The negative ion here is bromide, so you get bromine. Here, copper chloride. Copper is positive, chloride ions are negative, so you get chlorine made.